Hi, in order for you to understand indicator 9, which is equivalent expressions, I want to do a quick short video on understanding the basic vocabulary of like terms and unlike terms, a little bit of factoring and distributive property in order for you to really understand what we are going to be doing in this indicator on equivalent expressions, okay? So basically, if I say like terms are terms which have the same variable and they have the same exponents. So if I say 2 and I have 3, these are like terms because I can add them or I can subtract them. So if I say 2 plus 3, I get 5 because I can add 2 and I can add 3, okay? If I say 12x minus 5x, I can definitely take away 5x from 12 because I have 12 x's and then I have 5 x's. I can remove 5 x's from 12 x's because I have the same variable. Same thing if I have 8x squared and I have another 3x squared because I have exactly the same exponent and the same variable. I can add or subtract these, okay? So that's what like terms mean. Unlike terms are when they have the same variable but different exponents, okay? Or they have different variables with the same exponents. In that case, they are not alike, so they are unlike terms, and that is why you cannot add or subtract them. You can't do a 5x plus 5y because the x represents something else. The y represents something else. You can't just add unlike terms. It's the same thing, like I can say 5x plus 10 and I can't make it 15x. It's totally unlike. We can't do that, okay? So unlike terms cannot be added or subtracted like that, all right? It's only like terms that can be added and subtracted, all right? So let's try a few problems. Just wanted to show this to you. So if I have something like x plus x plus x plus 2, we've already done if there is no number, no coefficient that you can see written in front of a variable, because a variable is representing a number. So that means how many x's are there? That basically means there is one x, all right? So here's one x, here's another x, and here's another x. So how many x's do we have together? That is 3 x's, right? So we can, because they are like terms, we can add them, and that gives us 3 x's, and we have 2. Now, we can see there are 3 x's, and we have a number. So these are now unlike terms. We cannot add it any further. Please do not do 3 plus 2 and make it 5x because it's not 5 x's, okay? You have 3 x's and you have the number 2. So this becomes your final sum over here, okay? That's your final answer, all right? So same thing. Let's look at this one. We can see we have one j, and then we have another j. Nothing else is common. So here we have 2 j's. So this is 2 j's. And then we have 2 k's. Nothing else is common. So here is your final answer. So we are combining like terms, okay? Let's look at this. Now, since we have addition here, we are going to change the grouping, and we have done the properties. So we are going to change it based on the associative property, where we are changing the grouping. So this is going to become this now, right? Because z and z are like terms, so we can add these two together. And so z plus z, that is how many z's do we have? We have 2 z's. So that is 2z plus the number 6, which is an unlike term from the 2 z's. And so then this is my final answer. All right. Now the next one, this is distributive property, which we have done before. And the distributive property, basically this means that we are multiplying the number which is outside with each term inside. Okay. So I'm going to do 4 times 4a plus 4 times 5. So 4 times 4 is 16a because you're multiplying, plus 4 times 5 is 20. Okay? So now, since this is a different term than this has a variable attached, this is a number, so this becomes my final answer. So this is the distributive property which we have done way ahead in the beginning of the year. Okay? And then this one here, so we have 3x over here, and then we have the distributive property over there. So we want to make sure, remember your order of operations, okay, PEMDAS. Yeah, we definitely do the parentheses first, but since we have different terms, that's not possible. We're going to do the distributive property first now. So therefore, we are going to do this first, okay, before we do the addition. So this is 3x plus 3 times x is 3x plus 3 times y is 3y. Okay, and so now we can see that we have like terms. So we have 3 x's and we have another 3 x's. So we take 3 and 3, which is 6 x's plus 3y. Now these are unlike terms, so we can't add them any further. And this becomes my final answer. So just wanted to show this to you before we go more in depth into indicator 9, that is equivalent expressions, so that you have an idea of like terms, unlike terms, as well as distributive property. And one last thing also I want to show you is factoring. So if I had, let's say, 10x plus 20y, and it said find an equivalent expression, I could look at 10 and 20, and I can see that 10 is something which is common, right? So I can always take that 10 and I can put it outside, okay, because, and then what do I have left? If I have taken, see, this is what I've done. I've taken the 10 and I've taken the 20, and I am finding the greatest common factor, which is 10, right? And so then I get 1 and I get 2, and here's my greatest common factor. So then I am just basically going to do this, if you remember what we have done in the past, okay? And so then, since this gives me what? 1. So I have 1, which is x left, because 1 times x is x. And I have 2, because 2 times y, that's what's left over here. So look, 10 times x is what? 10x. 10 times 2 is 20y. So this is a method of factoring, and this is another thing that you will see when we get into this lesson on equivalent expressions. All right, so further on, this is just part 1 of introduction, and then we'll delve into this with the second part on this video. Have a nice day.